There's this hidden world all around us. It's the world of machines, the conveyor belts, pumps, and engines that literally power our lives. For decades, they've been speaking a secret language, and we've been trying to figure it out. Well, a revolution is happening. We're finally learning how to listen.
So here's our game plan for today. We're going to start with the huge, expensive problem of machine failure. Then we'll track how our whole approach to maintenance has evolved. After that, we'll zoom in on how you can actually listen to a machine's health, put some AI models to the test, and finally, wrap up with what this all means for building a smarter, smoother world. Okay, let's dive right in with the stakes. Pretty much everything you rely on, from your Amazon package to the lights in your house, depends on some machine running flawlessly. But what happens when it doesn't? What's the real cost? Just look at this number for a second. $50,000. According to Lafayette Engineering, that's what a single hour of downtime on a big conveyor system can cost a business. That is an insane amount of money, and it puts a ton of pressure on keeping these things running. A breakdown is way more than just a little hiccup. And it's not just the cost of the one broken part. It's a domino effect. One failure sends ripples through the entire operation. Productivity just dies. Safety risks go through the roof. Other parts start wearing out faster. It's this whole cascade of problems, all because one component decided to give up.
So for the longest time, our big strategy was pretty simple. Wait for something to break and then, fix it. Turns out that's a terrible way to run things. So our whole philosophy on maintenance had to get a lot smarter.
To make this a bit more real, let's look at a super physical, hands-on task, aligning a pump shaft. It's a whole process, right? You've got inspections, rough checks, then you break out the precision lasers, make tiny adjustments. It's all very careful, methodical work. But what if you could know the alignment was off before it ever caused a problem? And that question leads to this huge shift in thinking. The old way, preventative maintenance, is like your yearly doctor's appointment. You go on a schedule no matter how you feel. The new way, predictive maintenance, is like wearing a fitness tracker 24/7. It's constantly monitoring your vitals and only alerts you when it actually senses something is wrong. That idea, listening to the machine's actual condition, is the real game changer.
Okay, this is where it gets really, really cool. How do you get that real-time data? Well, you learn to listen. And to do that, we're going to focus on one of the most common little parts in any machine that spins, a simple ball bearing.
The magic trick here is something called vibration analysis. And seriously, the best way to think about it is like a doctor's stethoscope. You place sensors on a machine, and you can literally listen to its internal heartbeat. You can diagnose its health without ever having to take it apart. Now take a look here. On the left, you've got a perfectly healthy bearing, and on the right, that's its vibration signal. See how stable and predictable that line is? It's just humming along. That is the sound of a happy, healthy machine. This is our baseline for normal.
And here's the opposite. On the left, a bearing with just one tiny defect. But look at its signal on the right. This particular chart measures something called kurtosis, which is just a fancy way of saying it looks for sudden, sharp spikes. And yeah, you can see them. It's not a calm hum anymore, it's total chaos. Those spikes are the machine literally screaming that something is wrong.
So we can hear the problem. But can a computer learn to understand this language all by itself? This is where a fantastic study from the University of Sunderland comes in. They basically set up an AI challenge to see which algorithm would be the best detective at predicting these failures.
So the researchers lined up a bunch of different AI models. You can think of them as 5 different detectives, each with their own special way of analyzing clues. They fed all of them the exact same vibration data and asked a very simple question. Can you tell me if this bearing is healthy or if it's about to fail? And the results came in, and wow, it wasn't even a close race. Some of the models did okay, but one of them, XGBoost, just left everyone else in the dust. Look at that. 96.61% accuracy, nearly perfect. But here's the real kicker. Check out the training time. Less than a single second. So it wasn't just the smartest detective, it was by far the fastest. Now, this is more than just a cool academic experiment. Having an AI that's this good and this fast has massive real-world implications. It takes us right back to that $50,000 an hour problem we started with.
And you don't have to take my word for it. The researchers themselves summed it up perfectly. They said XGBoost gives the best trade-off. In other words, it gives you incredible performance without needing a supercomputer or days of training to do it, which makes it perfect for the real world.
So what does this all add up to? It means we can finally stop guessing and start knowing. It means less unexpected downtime, which saves companies a fortune. It means our machines last longer, our workplaces get safer, and the supply chains we all depend on just become way more reliable. It's a fundamental upgrade to the very backbone of our economy. And that kind of leaves us with one last big thought. We started this whole journey by listening to the tiny vibrations of a simple ball bearing. But this technology, this ability to find hidden patterns in data, can be used almost anywhere. So, if we can teach an AI to hear when a machine is about to break, what other secret languages are all around us, just waiting for us to finally learn how to listen?